Page 372, lesson 6.2 is on solving systems using substitution. So yesterday we talked about how we could graph equations if we were using our graphing calculator, especially find where the graphs intersected. This is going to be one of the methods in this lesson. This is one method that we can use to figure out our solution without graphing the equations. This is working it out by hand and figuring the answer. So substitution method, just like it sounds, is we're substituting something in place of a variable. So if you look at problem 1, it says what is the solution of the system, use substitution. So for this one, since this first equation says y equals 3x, kind of like if you were doing a problem and it said y equals 5 and we put a 5 in place of the y, it's kind of the same concept here. So with this one, it says y equals 3x, means we're going to put a 3x in place of the y in this other equation. So if you do that, like you can see they did here, they put a 3x in place of the y. Once we've done that, what that does is that gives us just one variable. And if we only have one variable, then we can solve the equation. This is a 1x. You can combine those, would be 4x. And then divide by 4, and you get x equals -8. That's the x value of where these lines would intersect each other. Once you have that, you can substitute that into the other equation. And this, you can substitute it into either equation. This is going to be the easier equation because the y is already by itself. So if I put a -8 in place of x, I work that out, and I get -24, so y equals -24. That's the y value of where the lines intersect. So that tells me my solution then is -8, -24. In other words, these lines intersect each other at that point. And this is really what I'm going to be looking for in order to use this method for substitution. I'm going to be looking for one of the equations to be either y equals something or x equals something, okay? As we learn the methods, if it's not y equals something or x equals something for one of the equations, with what we learn later in the chapter, if it doesn't have that, I'm not going to use substitution, okay? So we're going to find as we go through and learn how to do these things, we're going to learn what the easiest method is, and that's probably going to be your best choice when you're solving these. So if we look at the got it, they want us to find the solution of this system, and it says use substitution. On your test, I'm not going to give you a certain method other than if there's a problem that I say you can use your graphing calculator for. One thing you may want to do when you're working these problems out, depending on the situation, is writing the equations next to each other. And then you have room underneath both of them for solving. This one's a little different than the problem we just looked at because both of these have y equals something. If they both have y equals something, it really doesn't matter which one you substitute in where. It's going to be the same difference. It's just a matter of what's on the left side or right side of your equation. So if you want to say, I'm going to take this and substitute it for this y, you can do that. If you want to do the opposite, it's fine. It's either going to be x minus 1 equals 2x plus 7, or it's going to be 2x plus 7 equals x minus 1. It's going to be the same either way, okay? And again, we can do that because it says y equals this. If y equals this for one of the equations, we substitute, and then this works out that we're able to find where these lines intersect. So if you want to put a 1 in front of the x on the left side here, we're going to try to get the variable on one side, so let's get rid of the smaller coefficient term. So if you subtract 1x, and then try to now get the variable by itself, they're adding 7, so subtract 7. And then that's 1x. If you want to divide by 1, you can, but it's not going to change anything. So that's our x value, which is -8. And then what I've done, since I wrote these equations next to each other, then what I can do is I can then substitute a -8 for x here, and I can figure out my y value is -9. And then make sure for your final answer you get those together as an ordered pair, -8, -9. And these are ones on your homework anyway. If you worked this out and you wanted to check your answer, you could graph it on your calculator and make sure that you get that same intersection point. If you look at problem 2, it says for us to use substitution, one of the equations must be solved for a variable. So problem 2, after we go through a couple more sections, if you get a problem like this one, you're probably not even going to mess with substitution because we're going to find a different approach that you can take. For right now, that's all we know besides graphing, so we'll go ahead and go with it. This one's not terrible. But the idea is neither equation is solved for x or y. If you'll notice, there's only one term that doesn't have a number in front of it. So that's the one I'm going to focus in on, and that's what the book did here. So they said, let's get that one solved for y. So if we just add 2x on both sides of the equation, that gets y by itself. Now we can substitute. So you can see that's what they did here. So they put in 2x minus 3 in place of the y. This time when they did that, there was 3 out in front of that, so they had to distribute that, which gave them 6x minus 9. Also, we have like terms here we can combine since they're on the same side of the equal sign, and that would be 10x. They kind of did 2 things at once here, so maybe let's not get too carried away. But then you could add 9 on both sides, and you could get this, and then divide by 10, and then that would be 2 3/10. So 2 3/10, maybe not the nicest number, but we can deal with it. Then they substituted that into the other equation. If you wanted to, the one equation we already had as y equals 2x minus 3. So if you wanted to, you could put it into that equation since the y is already by itself. If I have the variable already by itself, that's going to be less work for me to do at that point. Okay, so either way, but that would be your solution for that problem. So if we look at the guide at 2, we've got a similar situation here. Like I mentioned earlier, probably would be good to write these equations next to each other. Oh, this one's a little different too. Watch out for this because it has 6y plus 5x. Normally, they put the x first and then the y is standard form, but okay, so just like the example in your book, similar to that, notice in the second equation, we have an x that doesn't have a number next to it, doesn't have a coefficient in front of it other than we could put a 1 there. So that's what I'm going to solve for. So if you subtract 3y on both sides of that equation, then we can substitute in. One thing I like to do also when I'm working these problems out, hopefully you find it helpful, but then also I find it helpful whenever I'm checking on your tests and things. If you draw arrows and even, can number your steps of what you're doing, then that makes it nicer to be able to look at and figure out if you missed something, why did you miss it? And then that works also with your homework, that we can figure out if you missed a problem, why you missed it. So then we can distribute here. If you want to do an extra step of showing what you're multiplying, you can. If you're at a point where you can just multiply it as you go, that's fine. Just make sure you remember to multiply to both of those. At this point, we have these y terms on the same side of the equation we can combine. Would be negative 9y. Then they're subtracting, so we can add 35 on both sides. And then finally divide by negative 9. That's not going to come out evenly, so I'm not even going to mess with my calculator. Negative 43/9. Okay, sevenths, ninths, a lot of those are not nice decimals. You can try it if you want, but it's not going to work out well, I don't think. So then from there, okay, I'm drawing an arrow back again, so like I said, we can see the progress of how we worked this out. Let's put this negative 43/9 in place of y and see what we get. So there we've got negative times negative is a positive. If you want to reduce the 3 and the 9, you can. And then we need to get a common denominator. And then when you work that out, that would be 22/3. So our final answer is 22/3 negative 43/9. So that didn't come out real great, but we can handle it. We're okay no matter what they give us for a problem. Problem 3, they're giving us kind of a real life scenario here. We have a snack bar selling different size of snack packs. Large is $5, small is $3. So if they sold 60 snack packs for a total of $220, how many small snack packs did they sell? All right, so we have two equations we can make out of this. One is by the fact that they sold 60 of these snack packs. Okay, based off of that, if X is the number of large snack packs and Y is the number of small snack packs, we can make an equation for that. Would be X plus Y equals 60, just based off of how many we sold. Altogether would be 60. And then we could also make an equation by the amount that they took in. So $5 each for the large, that's 5x, 3 each for the small, that's 3y, and that altogether adds up to 220. So those could be our two equations. With having those two equations, you'll notice the first one, the x and the y, neither one have numbers in front of them. It's not solved for x or solved for y, but there's not numbers in front of either one of them. So it's up to you. You could go either way. The book chose to go ahead and subtract x on both sides here. They solved that equation for y. And then they substituted it. This is like their second equation, okay? They substituted that into their second equation. Then they distributed. They combined like terms. And then also the same step, they subtracted 180. And then they divided by 2 and got x equals 20. And then once they know x equals 20, once again, I wouldn't do the same thing as the book here. They're okay, but I already had y equals 60 minus x when I solved that equation. So once I got that 20, I'm just going to put it into there and get 40. It's not a big deal, but just a little minor detail. So 20, 40, which means, well, the question was how many small snack packs did they sell? Y was the small snack packs, so that would mean they sold 40 small snack packs. and they also sold 20 large snack packs in case anybody was interested. Okay, and one way of doing that, once you get that answer, one thing that would probably be a good idea would be to check that into this equation. We know it's 60 total, that's easy to check. But if we check this, if we do 20 for X and 40 for Y, do we get $220? And the answer is yes, then we know we've got the right answer. So the got it 3 is similar to this. We're paying for renting video games. And we're trying to figure out how many new games we rented. So first, come up with your 2 equations, and then set it up where you solve for one of your variables, and then you can substitute. So as we set up our equations, a lot of times the money part sticks out to people, and they come up with an equation for that. And so for that, you know, if we have X would be our number of new games, we should be more formal and say let X represent the number of new games, but and then Y is the number of older games. Then for the costs, it's $4 per new game, so that'd be 4X, and then $2 for the older games, so 2Y equals 22. And then the other equation, it says that we rented 6 video games altogether. So the new games that we rented plus the older games we rented adds up to 6, would be our other equation. When you have these equations, notice neither one of them is solved for X or Y. So we're going to have to solve one of them for X or Y in order to use substitution. The second equation is going to be much nicer to substitute because there's not numbers in front of our variables. In fact, not in front of either one of them. So it's up to you which one you want to solve for. If you'd like, you can subtract X. And then we've got Y equals 6 minus X. And then now we can substitute that into our other equation. Now we're ready to distribute. So 2 times 6 is 12 minus 2 times X is 2X. And at this point, we've got these X terms on the same side. We can combine 4X minus 2X is 2X. So 2X plus 12 equals 22. And now we're at a 2-step equation, so no problem now. They're adding, we subtract. They're multiplying, we divide. And then once we've got that, we're ready to go. We've got space underneath here. X is 5, so Y equals 1. On these problems, a real life problem, we don't always necessarily write the ordered pair like 5, 1, because it's more of an interest of, you know, how many of a certain item did we get or whatever. So the question here was how many new games did you rent? So new games we did was X. So we could say that we rented 5 new games. Technically then, if that was what we were doing is trying to find X, technically once you got X equals 5, you could stop there and not substitute to the other equation. But if you have like an extra minute or something, I would do that, and I would also substitute into that cost equation. Okay, we take that cost equation that we had and just make sure that that adds up to $22. Then we know we've got the right answer. problem 4 talks about what happens if our variables cancel out, which we've talked about before with other equations. So problem 4, it says how many solutions does each system have. So on that one, part A, this is already solved for x, so we can substitute that into our other equation. And then when they distributed, and then when they combined like terms, they got 14 equals 14. The variable is gone. We have 14 equals 14. And so that's a true statement. So like we've said before, that means we have infinitely many solutions. Infinitely many solutions that would work. In other words, an infinite number of points that will work. And the reason that is because, like we talked about in the last section, these lines are the same as each other. Okay, I know the equations don't look exactly the same to start with, but they're actually equivalent to each other, and so that's why we have infinitely many solutions. Part B, same idea. The first equation is solved for y, so we can substitute in place of that. And then when you combine your like terms here, you get negative 11 equals negative 13. Negative 11 does not equal negative 13, and so since we have a false statement, that means we have no solution, which means the lines don't intersect, which means we have parallel lines. Okay, parallel lines, they're not going to intersect, so we have no solution. On the got it, this is not at all set up well for substitution. If you look at all these numbers, they all have numbers, or if you look at the variables, they all have numbers in front of them. And even, if we were going to try to solve for one of them, like looking at that top equation, if I was going to try and get x by itself, eventually I'd have to divide by 5, and I'm going to get all these fractions. If I would solve for x, I would divide by, or solve for y, I would divide by 6, and I would get fractions. Same thing in the other equation. Okay, I'm going to have fractions any which way when I solve for a variable, and it's going to be kind of a mess. And so my suggestion is, I'm just going to tell you, we're not going to do this by substitution with that equation, and so we're not going to worry about that problem. We'll find in another section, we'll find an easier way to solve that problem. So if we look at the lesson check number 5, we have a talent show, singing and comedy acts. Singing acts are 5 minutes long. Comedy acts are 3 minutes long. There are 12 acts, and it lasts 50 minutes. So how many singing acts and how many comedy acts are in the show? So just like we did on that problem earlier, let's come up with 2 equations, and let's solve this. If you want to, you can do S for singing acts, C for comedy acts, or you can just use X and Y, however you want to do that. So I'm going to go ahead and just use S for the singing acts and C for the comedy acts. But like I said, if you want to use X and Y or something, you can. So one of the equations based off of the times, we could make an equation. So if the singing acts are 5 minutes each, that would be like 5S plus comedy acts are 3 minutes each. That would be 3C equals 50 minutes total. The other equation is going to be based off of the fact that there are 12 acts altogether. So we could say S plus C equals 12. So this equation here, you can solve it for S or C, either way. And then we can substitute that into our other equation. Distribute. Combine like terms. Get the variable by itself. And divide. One thing to make sure on this problem is that you're getting a positive answer. We can't have negative x. And then substitute that in. So that should represent, then we have 7 singing acts and 5 comedy acts. And you can verify that that works with the amount of time that we have as well. So this gives you an idea of how to solve systems using substitution. Have a good day.